Hello, good afternoon, students. In this video, I am going to explain about various methods of estimation of design flood. These methods are broadly classified as rational method, empirical flood formula, unit hydrograph method, flood frequency studies, and envelope curves. Rational method. In this method, it is assumed that the maximum flood flow is produced by a certain rainfall intensity which lasts for a time equal to or greater than the period of concentration time. This concentration time is nothing but the time required for the surface runoff from the remotest part of the catchment area to reach the basin outlet. When a storm continues beyond concentration time, every part of the catchment would be contributing to the runoff at outlet, and therefore it represents conditions of peak runoff. The runoff rate cubic meter per second corresponding to this condition is given as Q. Q is equal to 2.778 CIA, where A is the area of the catchment, that is in cubic square kilometer. I is the intensity of rainfall, centimeter per hour, and C is a runoff coefficient to account for the abstractions from the rainfall. The maximum rainfall intensity depends on duration and frequency. The intensity of rainfall should therefore be corresponding to duration equal to concentration time and desired return period. This requires an estimate of concentration time, which is usually provided by an empirical equation given by Kirpich, that is Tc. Tc is equal to 0.0195 capital L to the power of 0.77 S raised to minus 0.385, where Tc is in minutes, L is the maximum length of travel of water along the water course in meters. S is the slope expressed as the ratio of difference in elevation between the remotest point and the catchment outlet to the length L. Once the concentration time has been determined, the rainfall intensity can be determined using the intensity, duration, and frequency relation applicable to the catchment area in question. Choosing an appropriate rainfall frequency. The frequency adopted may vary from 5 to 50 years depending upon the time and importance of the structures. Once the rainfall intensity and catchment area have been obtained, a runoff coefficient applicable to the given design condition is selected and the peak flood estimated from above equation. Some typical values of the runoff coefficient C are the type of surface in the table, it is given in the table form. Type of surface, value of C, cultivated, pasture, forest, with above average infiltration rates, usually sandy or gravelly type of surface. Second is with average infiltration rates, no clay pans, loams and similar soils. And the third one is with below average infiltration rates, heavy clay soils or the silt with a clay pan near the surface, shallow soils above in pervious rocks. So there are three categories. One is the above average infiltration, the average infiltration rate, and below average infiltration rates. For above average infiltration rate, cultivated 0.20 and with average filter 0.40, below average infiltration 0.50. So next is empirical formula. On the screen you can see the empirical formula. Dickens formula is given. You can see on the screen. And the different types of areas are also given, like North Indian plains, North Indian hilly regions, Central India, coastal Andhra and Orissa. So they have given the constant value, that is 6 to 30 in northern Indian plains, 6, North Indian hilly regions 11 to 14, Central India 14 to 28, and coastal Andhra and Orissa 22 to 28. Next you can see the Rives formula, like this English formula and Nawab Jung Bahadur formula and the Jarvis formula. So the third one is unit hydrograph method. Unit hydrograph method, the UHC technique can be used to predict the peak flood hydrograph if the rainfall producing the flood infiltration characteristics of the catchment and the appropriate unit hydrograph are available. For design purposes, extreme rainfall situations are used to obtain the design storm. So flood frequency studies, hydrologic process such as the floods are exceedingly complex natural events. They are resultants of a number of component parameters and are therefore very difficult to model analytically. And the last one is the envelope curves. In the envelope curve method, maximum flood is obtained from the envelope curve of all the observed maximum floods for a number of catchments in a homogeneous meteorological region plotted against drainage area. So this is about the estimation of the flood uh, and the various methods of estimation of design flood. Thank you.